Our solar system is a vast and wondrous place. It is a cosmic dance of planets, moons, asteroids, and comets, all held in the gravitational embrace of a star we call the Sun. For centuries, we have looked up at the night sky, charting the paths of these celestial wanderers. We know of 8 official planets in this grand system. Starting closest to the Sun, we have the small, rocky worlds, Mercury, Venus, Earth, and Mars. These are the terrestrial planets, our immediate neighbors in the cosmic street. They are worlds of rock and metal, each with its own unique story etched into its craters and canyons, telling tales of ancient impacts and geological upheavals. Beyond the inner, rocky planets lies the asteroid belt, a vast collection of cosmic rubble, the remnants of a planet that never formed. Past this boundary, we enter the realm of the giants. First is Jupiter, a colossal gas giant so large that all the other planets could fit inside it. Then comes Saturn, the jewel of the solar system, with its magnificent rings of ice and dust. These are gas giants, worlds made mostly of hydrogen and helium, swirling with immense storms and powerful magnetic fields. They represent a different kind of planetary evolution, one of scale and grandeur that dwarfs our own terrestrial home, reminding us of the sheer diversity of worlds that can exist. Further out, in the cold, dark depths of space, we find the ice giants Uranus and Neptune. These worlds are smaller than the gas giants but still enormous compared to Earth. They are composed of heavier elements with atmospheres of hydrogen, helium, and methane, which gives them their beautiful blue hues. For a long time, our planetary tour ended here. Many of us grew up learning about a 9th planet, Pluto. However, as our telescopes became more powerful, we discovered that Pluto was not alone. It was just one of many small icy bodies in a region called the Kuiper Belt. This led astronomers to reconsider what it truly means to be a planet. To bring order to our cosmic catalog, the International Astronomical Union established 3 rules for planethood. First, an object must orbit the Sun. Second, it must have enough gravity to pull itself into a nearly round shape. And third, it must have cleared the neighborhood around its orbit, meaning it is the dominant gravitational force in its path. Pluto meets the first 2 criteria, but it shares its orbital space with countless other icy objects in the Kuiper Belt. Because it has not cleared its path, it was reclassified as a dwarf planet. This decision was not about demoting Pluto, but about refining our understanding of the cosmos. The story of a potential new 9th planet begins where Pluto's tail changed, out in the frigid, dark expanse of the Kuiper Belt. This is a massive disk of icy bodies, a graveyard of primordial material left over from the formation of the solar system some 4.6 billion years ago. It is a region of profound mystery, where the sun is just a bright star in the sky. For years, astronomers noticed something strange about the orbits of some of the most distant objects in this belt. A handful of these remote worlds seem to be clustered together, their elongated orbits all pointing in the same direction, as if they were being shepherded by an unseen gravitational force. This peculiar alignment was the first major clue. It suggested that a massive hidden object was lurking in the outer darkness, its gravity tugging on these smaller bodies and shaping their paths through space. This is the essence of the Planet 9 hypothesis, a theoretical, unseen planet whose presence is inferred from its gravitational effects on others. Recently, a team of astronomers from the University of Taiwan added a new, tantalizing piece to this puzzle. They decided to look for direct evidence of this hidden world, not with visible light, but by searching through historical archives of infrared data, which can detect the faint heat emitted by distant, cold objects. The researchers painstakingly analyzed decades of data collected by 2 powerful space telescopes, the Infrared Astronomical Satellite, or IRAS, and the Akari satellite. These missions scanned the entire sky in infrared light between 1986 and 2006, creating a vast library of celestial heat signatures. The team was looking for a faint moving object, a slow-moving blip that changed its position over the years against the backdrop of distant stars. It is like looking for a single specific needle in a haystack the size of the entire sky, a task that requires immense patience, powerful computers, and a deep understanding of how objects move in our solar system. Their meticulous search paid off. The team identified a candidate object that appears in 2 separate historical images, seemingly moving in a way that is consistent with a very distant planet. The data suggests an object moving slowly through the Kuiper Belt, right where theories predicted a massive perturber might be. While this is not yet a confirmed discovery, it is the most compelling direct evidence to date. These faint signals from the past could be the first whispers from a long-lost member of our solar system's family, a ghost that has haunted the edges of astronomical maps for years and may finally be stepping into the light. If these preliminary findings are confirmed, what would this new Planet 9 be like? Based on the infrared data and the gravitational models, astronomers are beginning to paint a portrait of this mysterious world. It is believed to be an ice giant, a planet similar in composition to Neptune or Uranus. Its mass is estimated to be somewhere between 7 and 17 times that of Earth, making it a truly substantial planet, far larger than any of the rocky inner worlds. This immense size means it would have a powerful gravitational pull, strong enough to shape its own form into a sphere, and crucially, to influence the orbits of other bodies across billions of miles. The proposed orbit for Planet 9 is staggering in its scale. It is thought to circle the Sun at an incredible distance, somewhere between 46.5 and 65.1 billion miles away. To put that into perspective, Neptune, our most distant known planet, orbits at about 2.8 billion miles from the Sun. This new world would be more than 15 times farther out. A single journey around the Sun, 1 year on Planet 9, would take between 10,000 and 20,000 Earth years. This means that since the dawn of human civilization, this planet would have completed less than one full orbit. It is a world moving on a time scale almost beyond our human comprehension. Given its extreme distance from the Sun, Planet 9 would be an incredibly cold and dark place. The Sun would appear as little more than an unusually bright star, its light and heat barely reaching this distant realm. Scientists estimate its surface temperature to be around -200 degrees Celsius, or about -330 degrees Fahrenheit. This is a cold so profound that gases like nitrogen and methane would freeze solid, blanketing the surface in exotic ices. It would be a silent, frozen world, shrouded in a perpetual twilight, a true giant of the outer darkness, existing in a state of deep freeze for eons. The discovery of such a planet would reshape our understanding of how solar systems form. We currently have two main categories of planets: small, rocky worlds near the star, and large gas or ice giants farther out. Finding an ice giant on such a distant and eccentric orbit would challenge our models. It might suggest that our early solar system was a more violent and chaotic place than we imagined, where planets could be scattered into the outer darkness by gravitational encounters with other giants. Planet 9 could be a lost sibling of Jupiter and Saturn, kicked out of the inner family gathering billions of years ago. Despite the exciting clues, we must remember that Planet 9 has not yet been officially found. The evidence, while compelling, is still preliminary. Science is a process of verification. To confirm the existence of this planet, astronomers need more observations. They must track the candidate object over time to plot its full orbit, and confirm that it moves as a planet should. They need to observe it with other telescopes, like the powerful new Vera C. Rubin Observatory in Chile, which is set to begin its survey of the sky in late 2025. This observatory is expected to find thousands of new objects in the outer solar system, and it may provide the definitive proof we need. The search is complicated by other discoveries. For instance, astronomers recently found another distant object, a dwarf planet candidate named 2017 of 201. This object has a wild, chaotic orbit that does not fit the pattern predicted by the Planet 9 hypothesis. Some scientists argue that such discoveries weaken the case for a single massive perturber, suggesting that the dynamics of the outer solar system might be more complex than we thought. Science thrives on this kind of debate and skepticism. Every new piece of data, whether it supports or contradicts a hypothesis, brings us closer to the truth. Finding a new planet in our own solar system would be a monumental achievement for humanity. It has been over 170 years since the discovery of Neptune, the last planet found through prediction. Confirming Planet 9 would not just add another world to our maps. It would fundamentally change our picture of our cosmic home. It would prove that there are still massive, undiscovered objects lurking in our own backyard. It would open up a new frontier for exploration and study, inspiring a new generation of scientists, engineers, and dreamers to look up and wonder what else is out there waiting to be found. The quest for Planet 9 is a beautiful example of the scientific process in action. It is a story of curiosity, of piecing together faint clues, and of pushing the boundaries of our knowledge. Whether Planet 9 exists as predicted, or if the mystery of the Kuiper Belt has another explanation, the journey itself teaches us so much. It reminds us that the universe is filled with wonders, and that we have only just begun to scratch the surface of understanding. The cosmos does not give up its secrets easily, but with every new discovery, we expand our perspective and find our true place within its grand and magnificent design.